Hello, this is Mrs. Huntley. We are in the supplementary package, or packet, I should say, from Module 7. We are looking into converting, terminating, and repeating decimals into fractions. So this is still part of the second lesson, and we will flip back to our notes page to take some notes. But I wanted to start off on page 7. So on page 7, we've got some decimals, and we need to convert them into fractions. Earlier in the lesson, we were taking fractions and we were converting them into decimals. Now we're going back the other way. So actually, this is not difficult, but it does require remembering our place values. So we remember that the first place value past the decimal sign is our tenths, and the second one is our hundredths. So if I'm saying this, if I'm actually saying it properly, I know we've kind of gotten in a bad habit of saying things like 0.35, and that makes it really easy to understand, but it's not technically correct. If I was saying this word or this number correctly, I would say it's 35 hundredths. So if I'm converting it into a fraction, I'm going to say 35 hundredths. And you're thinking, oh, well, that's easy. Am I done? No, you're not done because it's not simplified. If I look, 35 ends in a 5, 100 ends in a 0, so I know both the numerator and the denominator minimally will be able to be reduced by 5. I can divide 35 by 5 evenly and I get 7. If I divide 100 by 5, I get 20. And 7/20ths would be the simplified fraction of 35 hundredths. Okay, so let's take a look at our next one. 0.275, again, saying it incorrectly. This is our tenths. This is our hundredths. And this is our thousandths. So if I'm saying this correctly, it would be 275 thousandths. So I put it over 1,000. Again, I can reduce this fraction. The easiest one to see is, again, 5, because one ends in a 5, one ends in a 0. So I know 5 goes evenly into both my numerator and my denominator. When I do that, I might have to do some work on the side and do some long division and figure out what it is, but I'm going to quick cut to the chase and tell you that 275 divided by 5 is going to be 55, and 1,000 divided by 5 is 200. And if you're looking at it, you're going, hey, we've got a 5 here, we've got a 0 here, so I know I can divide by 5 again, and you're right. 55 divided by 5 is 11, and 200 divided by 5 is going to be 40. So 11/40ths would be the most simplified version of that particular fraction, or decimal, excuse me. All right, so when we have terminating decimals, it's pretty easy. Whatever the place value is what we're putting them over, and then we are reducing the fraction from there. So go ahead and pause the video and see if you can do the next one. Now when you have a whole number in front of it, it's just this part of the decimal that you're making into a fraction. So this would be 8. This would be a mixed number. So 8 is going to stay that whole number 8, and then you're going to do something with the 12 and put it over some number. Again, remember your place values. Use the other two as examples if you need to. Pause the video, see if you can get this one converted. Okay, so hopefully you were able to figure out that we would have our 8 as our whole number, and then we'd put 12 over 100. Now, the 2 and the 0 are both even numbers, so what I did to start breaking that down into a number that was a little bit more manageable is I divided both the numerator and the denominator by 2, so I got 8 and 6/50ths, but I went, hey, they're still even numbers, so I can divide by 2 again, and I got 8 and 3/25ths. Maybe you knew right off the bat that you were going to be able to divide your numerator and your denominator by 4. I just didn't see it. And honestly, when I'm looking at it, I should have seen it because 100 divided by 4 is, of course, 25, because think about 4 quarters going into a dollar. When I was doing it, I just started breaking it down. And there's no harm in that. Just like both of these examples, if you can't use a calculator, divide by what you see. If it's a 5, if it's a 2, um, just start breaking it down into numbers, and then once you get the number small enough, it should be something that is a little bit more manageable and you're able to break down. Now let's get into some fun. Let's do some repeating decimals. Actually, what I'd like to do is take this first repeater, and let's go back to the note page. That was remember on the last video I asked you to divide that note page into two pages so that we would have some room for this. So this 0.888 with the line over all the 8s. Go ahead and go back to your note page, and we're going to rewrite that there. So turning a repeating decimal into a fraction, and the one that we're going to use is 0.888 repeating. So our first step is to set x equal to the repeating decimal. So technically it's just 0.8 repeating. You don't have to have the 3 8s because it's not like there's a specific pattern here. But I want you to see all of the 8s when we are moving a decimal. So if we're setting x equal to 0.888 repeating, and then our next step is to multiply both sides of the equation by whatever power of 10 that gets the repeating decimal in front of the decimal place. And you're going, wait, what? We need to move our decimal, and don't write this down right now, I just want to show you. We need to move our decimal to the right, and what that requires is multiplying by 10, or if we needed to move it twice, we would multiply by 100. So right now, I'm just going to multiply both sides by 10. Even if you don't fully understand it, just track with me a little bit, and hopefully it'll come together. So I'm going to multiply. I'm going to rewrite the equation first of all so that you have an example here. So x equals 0.888 repeating. I'm going to multiply by 10 on the left side of the equation, multiply by 10 on the right side of the equation. And when I rewrite it, I'm going to have 10x equals, I move my decimal 1 to the right, so I'd have 8.888 repeating. Why do I still have 3 8s there? Because a repeating decimal repeats to infinity. It doesn't matter how many times I move my decimal over to the right. If I had multiplied by 100, I have 88.888. Does that kind of sort of make sense? I hope. So now what I'm going to do, my goal is to get rid of the repeater part. So how can I do that? What can I do to get the repeating part of the decimal to kind of go away for me? So I'm going to subtract x from both sides of the equation. But x is equal, up here, to 0.888 repeating. So if I subtract x from my left side of the equation, I can subtract 0.888 repeating from the right side of my equation because they equal each other. So on my left side of the equation, 10x minus x is 9x. On my right side of the equation, 8.888 repeating minus 0.888 repeating leaves me with just 8. Now I want my x by itself, so I'm going to divide by 9, and x equals 8/9. That's how I convert a repeating decimal. And hopefully you have the steps written down here and it's making sense to you. Let's go back and we'll try another one. So we did all of our work on the other page, so I'm just going to say x equals 8/9 here. See note page. for work. All right, so number 11. You know what? Let's skip to number 12 because number 12 is, number 11 is exactly the same as number 10. And I'm going to have you guys do that one on your own in just a minute. But number 12 is slightly different. If I set x equal to 0.27, 0.27, oh gosh, let me erase that so it's neat. Let me get it. I'm going to try to get a thinner pen here. For some reason, my pen keeps getting fat on me. So we're going to set x equal to 0.2727, repeating. Now notice if I move my decimal just 1 over, I'll get 2.727, and so that's not it. I need to move my decimal 2 to the right because I need that whole 27 to be in front of my decimal place. So I'm going to multiply both sides of my equation by 100. And when I do that, I get 100x equals 27.2727, repeating. I'm again going to subtract x from both sides because x equals 0.2727, repeating. So I'm going to subtract x, subtract 0.2727, repeating, and I have 99x on my left and 27 left on my right. Divide both sides by 99, and I have x equals 27/99. Now 27 and 99, I'm looking at them and I'm thinking they can be reduced. And I'm thinking about my factors of 27. 3 and 9 go into 27, and 3 and 9 are going to go into 99. Now I'm going to divide both my numerator and my denominator by 9. When I do 27 divided by 9, I get 3. And 99 divided by 9, I'm going to get 11. So the answer to this problem, 0.27 repeating, is equal to 3/11. What I'd like you to do right now is pause the video, see if you can get number 11 worked out, and then come back and check your work. Number 11, again, is very similar to number 10, so you're going to be multiplying both sides of your equation by 10 instead of 100, okay? So pause here and see what you can work out. Okay, so how did it go? I set x equal to 0.11 repeating. Then I multiplied both sides of my equal sign by 10. So I got 10x equals 1.11 repeating. Then I subtracted x, but since x equaled 0.11, I could subtract x from the left side and subtract 0.11 from the right side, 11 repeating. And I'm left with 9x equals 1. So divide both sides by 9 and I get x equals 1/9. Hopefully this is making sense to you. To summarize this lesson, now the lesson was actually a 2-day lesson. The first day we went over how to make fractions into decimals. So hopefully you remember this and you can summarize this situation where the numerator is being divided by the denominator. If you can divide your if you can prime factor your denominator into factors of 2 or 5, you know you're going to have a terminating decimal. If you prime factor your denominator into anything other than a 2 or a 5, it's going to be a repeating decimal. You continue doing your division until you see your repeating pattern, and your repetition bar goes only over that portion of the decimal that is repeating. So that's summarizing the first lesson that we had. The second lesson today, turning our decimals into fractions. You start off, if you have a terminating decimal, you put that decimal over the place value that you have, like 35/100 would be 35 over 100, and then you reduce your fraction from there. If you have a repeating decimal, you set x equal to the repeating decimal, you multiply by whatever power of 10 is going to get the repeating part of the decimal in front of the decimal, and then you subtract x from both sides to eliminate the repeating part, and then you just solve for x. If you have to, you need to reduce the fraction. I'm sorry, I went a little bit over 15, but that's because I was trying to come up with your summary for you. So I hope that you can summarize today's lesson. I hope this makes sense, and we'll have a little bit more practice in class. Have a good night. I'll see you tomorrow.